The Stantec ZEBRA is an early electronic computer manufactured in South Wales. About 55 were made and exported starting in 1958. In many cases, Stantec ZEBRAs were the first computers to arrive in universities, technical colleges, and laboratories. The ZEBRA was made by Standard Telephones and Cables Limited of Corporation Road, Newport. After the war, STC took over the No. 11 Royal Ordnance Factory in Newport. The ZEBRA was designed by the Dutch computer scientist Willem van der Pol. His design was the subject of his 1956 PhD thesis at the University of Amsterdam. ZEBRA is an acronym in Dutch that translated means a very simple binary reckoning machine. In 1984, Willem van der Pol received the Computer Pioneer Award of the Institute of Electrical and Electronic Engineers. He was the fourth person to be so recognized by this American professional and learned society. The National Museum of Wales has a later Stantec ZEBRA in its store north of Cardiff. It is in need of repair. Rod Delamere and Noel Cox were initiated into computing via a Stantec ZEBRA. This film records their visit to the store.
I think we're going down here, look.
This one?
Try that, yes.
Oh,
What
yeah.
about that?
Wow.
You've seen one of those before?
I vaguely recall it.
I can remember.
But
1960, I first saw one of those.
60, I was 61, yes, just a little bit behind
That's
you.
it, yeah.
Obviously not quite the appearance it had at that
No,
time,
no.
with all the skirts and the covers
No,
and all
exactly,
the
that's
rest of
right,
it on
yeah,
it.
yeah.
But in that respect,
Let's
oh
have
yes.
a closer look.
Yes, oh yes.
There we are.
Memories of many moons ago. Especially with the dial on the right.
That's it,
I
there we
remember
are.
that well.
Yeah, that's right, yep, yep.
And all the buttons missing your oscilloscope displays.
On
Voltmeter
that corner.
though,
That's right,
yes,
that's right,
yes,
yeah,
yeah.
yes, yeah.
But obviously all of the layout and the buttons and the speaker, of course, that went with the machine at that time, for which I never got my hands on. Never got my hands on the actual main console like this.
No, no, no.
It was all for engineers' purposes only, obviously, of course.
Yep.
But most of the time too, it behaved itself too for us at the time that we used to go to Newport to Stantec building.
Yeah.
Occasionally, if there was a hiccup, then you would get the instructions, go and have a coffee or sit yourself down
And
for a
come
while
back. That's
and
right,
come
yeah.
back when they'd
right,
overcome
yeah,
a particular
yeah,
problem.
yeah.
But it wasn't often, I'm glad to say.
Yeah.
And the first machines we did go and program were valve models. This is a solid state job, of course.
Yes,
transistor.
yeah.
Over George Street Bridge, turn left. Big building on the left,
Yeah,
Stantec
that's right, yeah,
building.
Yeah.
And
Yeah.
this is where obviously the birth of the first Welsh computer was born.
Exactly.
Through
Yes, yeah.
The auspices of ITT, who thought at that time that it was the ideal place with all the facilities of that factory
Yeah.
to put together
That's right.
the hardware in terms of the electronics and the drum and the panels, fabrication, construction, of course. All of this was made at the one site in Newport with some very skilled and capable people, let me say. I met a few of them when I was working there from late 60s, early 70s. They had been part of the team building this, and they were still working there on the different products, testing apparatus, special systems and so on. It moved on to. But they had experience of this, and they seemed to show great pride by token of the fact that they had been involved on computers like this. And when the day dawned, when obviously the bottom line read that obviously they were in deficit, they did have some commitments to some contracts and the transfer.
So I think some of these went to South Africa.
Did they South Africa? I know
so.
they went to Canada.
Yeah,
Yes,
yeah, I'm sure they went to South Africa.
Or a couple or whatever it was. 20 in total, I think, were shipped abroad. 20, 25, something like that. But this then got transferred to, I think it was Ilford or Romford, one of the other factories. And the way that it was being assembled and put together at that time, the people in Newport were rather critical about it, to say the least. Oh yes, they were hammers and screwdrivers and things that should never have been used on this and the drum and so on.
Yeah.
But there it is, obviously, all these years later. All these years
later. About 1960.
60 for you, 61 for me,
yeah. And my first introduction to computers, obviously.
Yes.
Within the next 12 months, IBM came along and in a sense took over.
That great big wave of change that occurred at that time with the introduction of new manufacturers. Yes, with this particular fellow too, the way that we used to speak with it was by paper tape, of course. Paper tape in, paper tape out. There was no other method other than
the dial.
This fella here, yes.
And you can put in
the fact
numbers.
that obviously you put in the program in simple code, an instruction to stop temporarily.
Yep.
Now that temporarily was for a limited time.
So you got to be quick.
So you had to be damn quick about it. Hopefully your numbers were the low ones, the 2s and the 3s and the 4s. But by the time you had to put in maybe a 0, it was a long way back, and then chop, up it went. And maybe missed a couple of digits along the way. But and we never played with the buttons. The buttons were obviously all standardly set. And a situation where, yes, via paper tape I should say, via paper tape going in, the diagnostics were just one function.
Yep.
If it stopped, it was wrong. If the paper tape stopped, it was wrong. There was a fault there. You'd put something in of an invalid character or whatever. So you had to kind of take the paper out, take it out, go to the position on it, try and print it out, see where the problem was, then get on one of the Westrex devices and get it translated and correct the fault and so on.
And try again.
And go again.
And try
until
again.
eventually.
You got the answer.
It might be a few times, but you got there in the end. Yes, that's right.
Yeah.
Except on the one occasion, which did tickle me, was I'd realised that across the five punching positions across the tape, there was one hole that wasn't needed, and that's what it stopped on. I forget the reason, but I thought I'll be clever here and I'll take a corner off an envelope with the gum on it, and cover up the hole.
That's right, so it fooled the system.
Oh yes,
But it didn't.
But of course that made the paper a bit thick.
That's right.
So I put it into the system and in it went. And it got to the position where I'd fixed things, and it stopped.
Right.
But I gave it a pull, and off it went again.
Good.
And it was right.
Yes.
More by luck than judgment.
That's what they call hands-on.
Oh yeah, that's right. I think you're right there.
No automation there.
That's right.
It was just pure.
Oh luck.
Pure luck. That's right.
But saved, producing a very long tape.
Yep.
And reproducing it again, of course.
Yep.
But they had one when later years later, when I went to work at the factory in '68, I think it was. They had one of these, the transistor model, not the valve model, the later one, of course. It was in one of the small offices on the cable site, Standard Telephones and Cables. Cables had and there was a fellow there called Don who was looking after it for technical calculations and such like, of a very simple nature in actual fact. But his years of knowledge, by being so close to the system, was such that if there was a fault, no spares available.
No.
No handbooks probably available either, I don't suppose. But obviously, by fair means or foul, he used to be able to, with, I don't know, paper clips and pieces of string and what have you, and get things going again. And it lasted to into the 70s, I think it did in that respect. But obviously, it then became to this position where it was all over finished, yeah. But as you see, it's a little bit undressed in this form, of course, without the panels on the front.
Right, you wouldn't always see all that.
No,
Exactly.
quite. That's right. All these things there
Which open up.
would not be visible.
No.
And you'd have a console here for the teleprinter, of course.
Yep.
Massive 10 characters a second,
That's
of
right,
course.
it was slow.
Oh, wow. Just like the old teleprinter years ago for the football results,
That's
wasn't
right,
it?
yes. Yeah.
And over there on that side would maybe be the tape reader
right,
and the punch as well, of course.
That's right, yeah.
Because you could, in fact, obviously, if you ran out of space on that drum in there, and let's have a look at the drum in a minute, you'd be in a position where you could produce a long paper tape with, obviously, a lot of data on. It would take a while to do that, of course. That could then become the input to the next program you load. So you could go on as layers of programs could work that way. I never had to do that.
No.
And there was always space for programs, there was always space for data, limited as it was. But if you were run out of space for the program, you could pinch some of the data space for program steps.
Right.
These were called point addresses, if I remember. And you could work it that way. So if we could look at the drum. The storage capability to enable, obviously, the main processor to handle all the information, follow the steps of the program, all stored here on a drum. This drum powered and rotates at 6,000 revs a minute. So quite fast and takes quite a bit of power, I would guess, that enabled you to store these, I think it's 1,500 steps and 1,500 pieces of data. Obviously, all of these wires here indicate that there is a head that's close to the surface, the magnetic surface of the drum, and information is transferred to the other end of this wire, is this magnetic head, where they store the program or the information. And that can be changed, obviously, according to the steps that you undertake. But it can, that was your absolute limit of inline information at the time. And obviously with all these harnesses going through to the different logic boards in the system in 3 cabinets. But the logic boards, these for example, these being wrapped joints, unlike solder, where you could obviously invite dry joints, wrap joints are guaranteed to work 99.9% of the time, obviously if you've got a problem. But it's lesser with wrap joints, where obviously the component on this side has 2 legs going through to the back of the board, and the 2 legs then are wrapped around the pegs, or the connectors are wrapped around the pegs, such that you get a firm and positive connection there. So STC and Newport were, in that respect, well ahead of the race on guaranteeing that their construction was positive and tried to be watertight, obviously, of course. But that was the heart of the matter, the drum, the magnetic drum.